This is our training for people who would like to design keyboards for indigenous communities. I'm calling this part 1, and then we have a part 2 that's going to follow on that Craig Cornelius is working on. He's going to cover the actual design considerations. I'm introducing a collection of principles around language and writing system design. So as I mentioned, part 1 today, I'm going to do a brief survey of language properties and principles that affect keyboard design, and then Craig will follow up with actual design challenges and solutions. I won't go through the agenda, but these are some of the topics we're going to cover. I think some of you are familiar with these topics, and some of you are not. So we're going to go ahead and cover these at a very high level. So let's talk about what a writing system is. And it's basically a way of visually representing what was traditionally verbal communication. And it's based on a script and a set of rules that are known as orthography. And a script is a set of base elements or symbols that are used to visually represent parts of communication. So the writing systems can be independent from language. You can have multiple writing systems for a language, and you can also have one writing system that is used for multiple languages, and we'll give some examples of that. So, but basically, the writing system is the collection of symbols and rules that you use to represent what was verbal speech. So how do you create these things? And first, we're going to decide on the symbols that we need. And as you might guess, we use letters, we use punctuation, we use numeric symbols or arithmetic symbols, and then you may use some other symbols that may depend on your application or what you need to cover by your writing system. So it could be currency symbols, it could be special symbols like copyright and the registration mark. It could also be some things like symbols used for temperature or math or science. If you were dealing with a market that is where music is important, you might have musical symbols. If you were in a strongly mathematical market, you'd have mathematical symbols, and you may also have other symbols that represent various concepts. Now, not every graphical symbol belongs in language. But we're talking about a process where you identify the symbols needed to represent the language and some symbols that may be included for certain applications. For example, if you needed navigation, if that was important in what you're writing about, then you might include navigation symbols. So examples of symbols that are not language related, but become part of the language if they're used often enough, might be these symbols for female and male, or the recycling symbol. If they are used in print often enough, and especially as a part of the language, then you would want to include them in your writing system and in your script. We move from symbols to the idea of characters, and in particular I want to talk about abstract characters. And we add the word abstract because we're now going to take our chosen set of symbols and give each one a function or behavior. In other words, it's semantics. What's its meaning in the context of the language? It can represent sounds, it can represent stress or timing or other aspects of representing speech. The semantics help define how the language is being represented. So now this semantic meaning or this abstraction is about concepts at some level. It's separate from how the symbols are drawn, and you'll see why in a slide or two. So we go from having symbols to characters with particular semantics, particular behaviors, and representations, and they may contribute to the spoken or written language rules, the orthography of the language. So some symbols, as I mentioned, are for oral or verbal purposes, pronunciation, tones, timing, stress. Some may be more specific to writing, for example, some typographic symbols, including things like white space or subscripts and superscripts, because how they are drawn is part of describing some of the semantic meaning. Some characters may also be included that are there in order to manage rendering or other behaviors. These are called control characters. So, for example, a language that is both written left to right and right to left may have a control character or several control characters that affect the direction of the writing. Other characters may be used to help define the shaping of characters. So there are characters that might join two characters for how they're written, or may take characters that are normally joined and separate them. And there may be control characters that, for example, give a variation to a character, so it is drawn differently. So the collection of characters is called a character set. And a character set may be a subset of a script. So as I mentioned, a script is a large collection of symbols, but specific to a language, you have a character set, which may be a subset of the characters in the script. And in some cases, it may include characters from several scripts. And as I mentioned, since the characters have particular functions and behaviors, we talk about the properties associated with a character. And there can be many properties. Character has a name. It may have a character type called, whether it's a letter or a punctuation or digit. It may also have properties that relate the character to other characters. For example, is it uppercase or lowercase? How does it sort? If ordering is important, what is the character's natural writing direction? And may also have properties like mirroring, which I'll explain in a couple of minutes. So Unicode defines many properties that characters can have, and every character in Unicode is a very large character set that includes all of the characters of almost all of the languages in the world. And it defines for each character properties it should have. I won't go through this list, but you can come back and look at it. And this is a short list. There are many more properties that Unicode defines. So we want to define abstract characters. We've come up with this set of symbols. We choose them from a script or multiple scripts. And we want to say, well, how should we work with these characters in this writing system? And it's important to know that characters don't have to be one-to-one to the symbol, the way it's drawn. For example, I can have this character A with a ring above, and it could be a single character. I could say I want to have a character that represents A with ring, and that's it. So when we do that, the character is called composed. However, it could also be two characters. It could be the character A, and we could have another character, which is a combining character, and it could have a ring above. So when I enter the character A and I follow it or precede it, we'll get into that at some point. With this combining character, it forms A with ring above. It's also possible you can have multiple combining characters after what we call the base letter. So here is a lowercase a, and I follow it with this circumspect character followed by a dot below. And this forms this character, which I think is used in Vietnamese. And it's presented this way. So we have composed characters and we have characters that are made of base letter plus combining characters. I want to mention that combining characters are sometimes called non-spacing characters, meaning they don't advance the cursor, and so they essentially combine, right? So a benefit of combining characters is they can be applied to other characters to form additional or new characters. So here I've taken the combining ring above and a combining tilde character and applied it to these base letters. And you can see now I've got all of these characters with tilde above and this ring character associated with A, B, and C. And this can be useful, especially in a world where we're always creating, language is evolving, we're creating new characters, or applications want to, such as math or science, want to add symbols for particular purposes. So that's one of the benefits. As a keyboard designer, the choice between composed and combined characters might be influenced by the speakers of the language that you're working with, right? Do they think of the character as a whole letter, or a letter with a diacritic or a tone mark or other annotation? So, for example, if I have the letter A with two dots above it, that's called the diaeresis. In German, you would say, well, it's the letter A followed with the diaeresis. It's a mark on top of the letter, being an accent or other indicator. But in Swedish, A with two dots is considered a whole character. So, and in fact, it sorts differently and it has different behaviors. So if you were designing your language and your writing system and whether or not to have the diaeresis be separate, you might take into account whether there's a need for additional characters with that mark and whether the speakers are going to think, oh, this is an A with two dots versus a character that is just a whole character. So I sometimes think of this in terms of the letter C and the letter G. Is a G a C with a line going through the center or partially through the center, or is it a whole character? And we're taught in English that it's a completely separate letter. But in theory, somebody could have said, oh, we're going to make this a separate mark applied to something that looks like a C. So this choice of how characters are abstracted is an important decision, especially for keyboard design. It can affect the number of keys that are needed. If you're doing all composed characters, that might mean you have more characters than if you were to use combining characters. And it could also perhaps be the other way around if you're not careful in your choices. It can affect your typing efficiency because now you might need to have more key presses, and it may affect how your users have to rethink, well, when I speak, I think this way, but now when I'm typing, because I'm using combining characters and I'm typing them in a certain order, maybe it causes them to pause or rethink or simply take more time with more key presses. There are some characters that reorder the characters as they're typed or reshape them. And I'll give you examples of that. And that may also come into play when you're choosing what type of abstraction you use. So to recap, because there's a lot here, you have a language, a spoken language. You try to map it to a writing system, which is a mix of the symbols you're using to write and the rules that apply to using those symbols. A language can use more than one script. One example is Japanese, which uses the kanji characters, which are the Chinese-derived characters. And then the Japanese also has a hiragana script and a katakana script, two different phonetic character sets. So, and then also a language may use different writing systems. So Azerbaijani for historic reasons, is written in the Latin script, it's written in the Cyrillic script, and it can be written in the Arabic script. So you need to be aware that as you think about keyboards, you may have to know which writing system is being referred to, which script should be used as a part of what you're trying to resolve when you create a keyboard. And when we talk about the writing symbols, they're usually chosen from a script, which is a collection of symbols, and it can get narrowed down to a character set. But bear in mind, the character set might also choose symbols from multiple scripts, as in the Japanese example. And you want to move to this collection of characters that you're going to use for writing to a level of abstraction for each characters where it's not about how they're drawn, but how they represent the semantics for each character in order to achieve the requirements of the language and writing in that language. I'm not going to go into it in much detail here, but I thought I should mention at this point, when you're working with a language, we often talk about its language tag. And in our questionnaire for people that want keyboards, we've asked them for their, I think we sometimes call it a language code, but technically we want a language tag, which consists of optionally 3 codes. A language code, which comes from ISO 639, which defines the language, but then it can include a script code from ISO 15924, which is a standard representing all of the scripts that are used in the world. And then, of course, optionally by a region code, which might refer to the country or continent or location where this language is used. So script and region are optional. So for English, it might be sufficient to just use EN as the language code, or if you want to distinguish, let's say, British English from American English, you would include the region code. And we generally wouldn't use the script code Latin because it's pretty much only written in Latin. But for other languages like Azerbaijani, you might include the script code in order to make it clear whether you're using Latin, Cyrillic, or Arabic script. You don't have to read this eye chart, but I thought I would include some of the codes. One of the points I'll just make about this is, if you're familiar with Hindi, you might look on this list of script codes and wonder, where is Hindi? Well, Hindi is written in the Devanagari script. So DEVA is the script that would be associated with Hindi and some other languages. So we want to talk a little bit about symbol shapes and semantics in a little bit more detail. We may have symbols that look the same, but they actually have different meanings and they require different abstract characters. You may also have symbols that look different, but essentially represent the same character. And I'll give you some examples. So in terms of symbols that look the same, we have this character A ring. And a character was added to Unicode, which looks identical. It's called the angstrom character. It was added because it appeared in some scientific character sets. And maybe at the time, it was given different properties. Same thing, or a similar thing for the Greek letter omega, which is also used for the ohm sign to reference resistance in a resistor. So these characters were duplicated. In the case of Unicode, they were duplicated so that you would have round-trip convertibility from the standards that contain these to the Unicode standard. They could be converted to Unicode, but then also return back to the original standard so there'd be no loss of information. Since these are pretty much treated identically in Unicode, this is mostly there for convertibility and legacy reasons. For typographic differences, there may also be characters that are similar. So we have these two characters. The relationship between them is mostly their sizing. The full width is the characters look to be the same size and have the same weight as other characters in the kanji characters. But when they're included with ASCII characters, Latin letters, they wanted a smaller one so that they would have the same weight. You have characters that are ligatures, where I and J can represent a letter, but they're drawn closer together to appear to be a unit typographically. And then, of course, we have superscripts and subscripts. And this is an example where the characters look the same, but they actually have different semantics, right? There can be many reasons. There are also where the characters look the same, but they're used in different writing systems. So here we have Greek, the Greek alphabet, and you can see that it has characters that look like the letter A and B and the letter E. And here is a Cyrillic alphabet, and you can see again the letter A and B, there's C, T, Y, E, right? Quite a few letters that look like Latin letters. So let me ask, if you run across this in a language that you're designing a keyboard for, should you use the same characters that you're using for the Latin alphabet? Why not just say, okay, I've already got these, I don't need to add characters, I will just reuse these?
I'm gonna say no.
And why?
Because, like what the same situation you had with Omega.
Yes. So what you're saying is because they have different semantics. Exactly. And so here we have these three B's, or characters that look like B. And supposing I want to apply casing to it and change the case to lowercase. If I only have Latin B, when I go to lowercase, it's only going to look like this. But in Greek, the beta letter has to go from this character, which looks like a B, but to the beta symbol. In Cyrillic, you have the V, and that's going to look like this in a lowercase letter. So the semantics are different, and in particular, the properties are going to be different. And because we need to have different properties assigned to each of these characters, they essentially need to be different characters. Now, the other thing we'll talk about is how the characters are actually drawn. So we have a glyph, right? A glyph is the drawing of a character. It's the image or rendering of a character. And characters can have more than one shape. So it could be based on the language. It could be the choice of font you make. So here are two characters, well, actually one character with two different shapes. It's drawn differently depending on Japanese versus Chinese. And if you change a font from a Japanese font to a Chinese font, the shape of the symbol will change. We have some characters that change their shape depending on the characters that are next to them, because some languages are, I'll call it cursive, where the characters connect and join, and how they are joined depends on which characters they're joining with. And some also make essentially gross changes, large changes in how the characters are drawn. So in Arabic, we have the character lam, and we have this character for aleph. But when you have a lam aleph together, it's drawn in a way that looks different from either character. Some characters may depend on the direction of writing. We have a property in Unicode which is called mirroring. And from a keyboard design perspective, we might need to think about this. So if I'm typing in a left to right direction and I want to open a parentheses, right? So you would have this left parentheses as I've drawn here. If instead I'm going right to left, and I want to open up a parentheses because I'm beginning a parenthesized set of text or numbers, then because I'm going right to left, I might want this right parentheses first. And so it raises the question, do I want to have characters that just represent the visualization left parentheses and right parentheses, or maybe I want to abstract it and have the idea that what I'm going to do is open parentheses. If I'm going left to right, I want this left parentheses. And if I'm going right to left, it should give me this other, this right parentheses. So the key I would type when I open parentheses would represent open, and it would change the drawing depending on which direction I'm writing. So that's a choice that would need to be made on how you think about the character. And that's also an example of the semantics, whether you're representing characters, strictly visually, or you're more conceptually saying this is open and closed. And in Unicode, there are several characters that mirror, which depending on the text direction will change how the characters are drawn. I have some other examples where position in a word makes a difference in Hebrew and Arabic, and we'll come back to that. Another example of how the glyph doesn't define the character. These are all the letter A drawn with different fonts. So you can see there are large differences there. And again, from a conceptual point of view, if I just wanted to represent division, I have a choice of two characters, and depending on what I'm representing, if I'm actually trying to represent the semantics of division, then I might choose either of these. And then you have superscript and subscript, and on the one hand, saying here's the symbol for 2, and it's going to be the same thing as superscript. That might not give you the behaviors that you want, because squaring something like in E equals MC squared is not the same as E equals MC2. So that's where you start to think about the semantics, not just how the characters are drawn. Of course, languages need to use digits, and here you can see the digits used with the Arabic language. And just a side note that in Arabic, for most numbers written in the Arabic script, numbers are written left to right, not right to left. So the most significant digit comes leftmost. And then we have the European digits, which are actually called Arabic digits. And even though they're European, Hebrew mostly uses these digits. There are also ways of counting with Hebrew characters, but that's used less often. Here's Thai digits, and here are Japanese counting characters. And you might also think about, at least from a keyboard perspective, whereas we use 2 digits in Latin or European script to represent the number 10, there is a whole character that represents 10 in the script. So, but most of these have the same properties in terms of values as digits. We also want to think about punctuation. I could give you lots of examples, but here we have typical quote marks, at least the typographic or smart quotes. In French, you might use guillemets. German has 2 different ways of using quotes, whether it's these quotes or I'll call them guillemets, but in a different order from French. And Swedish also has 2 different forms. And note here that in Swedish, this guillemet is different from the German one. And its open quote looks like it's closed quote. And then there are single quotes, etc. So we want to include punctuation. And when you're looking at a language, especially if you have a small number of samples of the language, it may surprise you later to learn that, oh, there's more than one way of doing it. There may not be one right way or one major way of doing these things. So we'll come back to writing direction. I've mentioned that some languages are written right to left. They're often also including left to right writing, so they're called bidirectional. And so the characters have properties known as direction, which it can be left to right or right to left, can be neutral, which means its direction is inherited from characters around it. There are other values depending on their use in numeric expressions and so forth. So all of these properties are designed so that as you write text, the text is ordered mostly correctly. It's not a perfect system. So there are also control characters that you can use to influence the direction. There are also other writing directions. Some languages are written vertically, and they can be written vertically with the columns proceeding left to right or columns proceeding right to left. And they're usually written top to bottom, but you can also find languages that go bottom to top. And also you have the Strephedon and languages where the writing direction alternates from left to left as you change lines. Pretty much every direction you can think of is represented by some writing system somewhere. Now, I'll ask you a couple more questions. Here we have Hebrew characters. Each of these characters has two forms. So what you're seeing here are pairs of characters. So you have the letter kaf, and then you have this other kaf, which is called final. It's used at the end of words. The same thing for these other characters, right through to the men, which is drawn differently as when it's the last character in a word. In Arabic, characters can have four shapes. This is the letter be, and if it's written by itself with spaces around it, it's called the isolated form. It's written like this. And then proceeding to the left, if it's the first character in a word, it's drawn this way. If it's in the middle of a word, it's drawn this way. And you can see that it has, connectors on both sides of it. And then at the end of a word, the final shape, it looks like this. So now, let me ask you, if you're designing a keyboard and if you're designing the character set, first of all, would you create a different abstract character for each of these four shapes in Arabic or the two shapes in Hebrew? And what do you think about your keyboard? Do you want to have a different key for each of the shapes? So essentially typing the visual form of each letter, or do you want to have one form and have your rendering take care of the drawing?
I'm going to say the last one, the rendering. Except fonts would probably be different. But as far as typing on a keyboard, I would think that it's the same letter, but I don't remember, but I think on a keyboard, it's kind of like a ligature in a sense, where it will know what came before or after.
Okay, so I'm not sure which is optimal. I like your idea that the rendering system can take care of it. For historic reasons, each of these characters has its own character in Unicode. I think if we were designing it today, it might not. I'll leave it there.
Unicode and modern software discourages using the different characters for the four different shapes, as I understand it, allowing the rendering software to do that and expecting the rendering software to do that as well.
We also have some writing systems that have very complex rendering requirements, and I'll give you some examples of that. They may have multiple diacritics, they may reorder the text, they may change shape, and they may also have some rules that prevent certain combinations. And some examples are Thai, Khmer, and some of the Indic languages. And here's one of my favorite examples. This is the word purti. In Hindi, it means fulfillment. And you essentially spell out P-U-R-T-I. But what you'll see is that the characters are positioned below and in front of other characters and are recombined. And I'll explain this. And so the question would be, maybe you want to design the keyboard the way the user thinks about the pronunciation or thinks about how they think about the characters that they're used to using before they were included on computers, or maybe more visually. So this is what happens when you type the word, right? So we type the letter pa, and it looks like that. And then we're typing the vowel sound, oo, and that essentially gets marked underneath the pa sound. So it changes it from a pa to a pu. And then you type the R sound, and it gets post-pended here. But then you type this virama, which is kind of like a glottal stop, I think. It changes the way the previous sound is made. So here's how it looks. And then you type the ta sound, and so now this gets added on. So the ta, if you look over here, you can see how it's supposed to look. It hangs from this descender, and it's got a line down and a little loop. Here you see the virama has now moved on top of this character. And then you type the vowel sound for E, and now that's been positioned. Look over here, you can see how it should look. That's actually been positioned before the ta, right? So you're going left to right, and all of a sudden this character is introduced, and it affects, it's positioned before it. So as you're thinking about keyboarding, do you want to introduce the I as something you type after ta or before the ta in order to change it? And, you know, as I mentioned, it depends on the history of other writing by hand before you get to the keyboard. May also be how the user thinks of the spelling, and you may have other thoughts about the efficiency of dealing with it in rendering versus dealing with it at a typing level and so forth.
I just also wanted to ask in terms of keyboards, because most of these languages are vowel based. So you have a long oo and you have a short oo. That is when you say vowel sign as U. Same goes with T. Whereas you have an E which is on this side, left side, as well as an E which is on the right side. And the way we were taught is you need to see, are you going to stress that letter, pull it when you speak, then you could always represent it as long or short form. So in keyboards, what is the concept like? Because that is one area which I am not aware. How do we represent two vowels? The long form and the short form?
I don't have a generic answer for you. There are options with the positioning of when you type. It could also be whether you have a long key press or a short key press or a double tap instead of a single tap.
Currently, that's the way we do it, because when you long press it, you get the other symbol. When you do a single press, you get the left-sided symbol. But theoretically, I just wanted to understand, is there anything else while designing these letters, or is it just press-based?
Well, it's also whether you could be whether you type before or after, or you could have control codes in addition to the character to change it. I can imagine all sorts of methods, and I think it depends on what the requirements of the language are and how the speakers think about it. So I don't think there's one answer. As we get into actual keyboard design, maybe we can do a study of other approaches. I'm just going to mention very briefly, some languages have huge numbers of characters. I think the Unicode for Chinese is actually closer to 100,000 since I've created this slide. But for very large character sets, we're not going to create a keyboard with thousands of keys. And so there are things called input methods which are essentially kind of virtual keyboards that you would use. And they have many different ways for choosing among those characters. And we'll come back to that when we work more with large character sets.